In this particular lecture, we're going to have a look at image ribbons. Image ribbons are fairly nice ideas. It's notionally an image that wraps around in itself to provide an endless ribbon. Image ribbons, they tend to be used quite frequently within, for example, platformer scroller games, where we want to provide some background graphics and to sort of continually give the appearance of a background that is infinite and is within its extent. How do image ribbons work? In the more general case, it is a sequence of images that we view them to be connected together and generally looped as well, so that whenever we get to the end of the ribbon, we loop around again to the beginning. We have, for all these things, a viewport, and that can move around relative to the ribbon, and whatever part of the ribbon that falls within the viewport, that's the one that we will end up actually drawing. Why do we do this? We say here the ribbons, they're quite often used to give the illusion of a moving background, and quite often they're decorative in terms of their purpose. So here's a situation where we have a world, and we have a number of different objects shown within the world, and the two sort of yellow lines that are going off into the distance, notionally they would identify that is our worldview, the objects that are within this. And here we give them a different position. Some of the positions will be within the viewport, other positions will fall outside of the viewport. Behind that, and this is where the yellow box comes in, that is our background. So the user doesn't interact with it, but we have a background image that is shown. And as the user moves, then the background itself also moves, and it gives the appearance of the user moving through an environment. This is an ideal opportunity to put in a ribbon at this place, and if it's a seamless ribbon, whenever we get to the end of it, we'll loop back around the beginning. So it's a nice way of giving the appearance of background to games. You can do more fancy things with ribbons, and if you have several of them and you scroll them at different speeds, you get quite a nice parallax effect. So here we have a total of 5 potential ribbons, and if we assume that we have a player, and the player, for example, moves 20 units within our game, then the layer closest or at the same level as the player, we would offset that by the same amount. And the layers behind the player, if the player moves 20 units, we would move them by a smaller number of units. And the further away we're drawing it, the fewer units that we would move it. So for example, the hills we might move by 10, the distant hills we might move by 5, and then the very, very distant ones way off in the background, we would only move those very gently. We could also have, for example, some clouds, and we're always continually moving the clouds, even if the player's not moving, to give the appearance of a changing weather system. So by combining another ribbons together, we actually can end up with quite a sophisticated visual effect within our game. We'll have a look at how we, in the most simple case, how we take a single image and turn that into a single image ribbon. And it's something you can think about first of all before we actually have a look at a solution. So assume here we have a ribbon. Now, just for sake of simplicity, the viewport and the ribbon are of the same height. So we're only interested in scrolling this along the x-axis. Also, for reasons of simplicity, let's assume that the width of the viewport is less than the width of the actual ribbon. So in other words, the viewport can potentially fit within the whole ribbon. It's big enough. You might want to have a ponder for a couple of minutes here about how you could draw the ribbon so that it occupies all of the viewport. And as the viewport moves and changes, you draw the different segments of the ribbon within it. And assume here that we have a looping ribbon, that whenever we get to the end of the ribbon, we'll redraw it from the start. So if you want to have a couple of minutes to ponder this. Once you've pondered it, there's actually a couple of cases that we need to be concerned with. The most simple case is the one we see at the bottom, where the image is fully contained within the viewport. The only challenge we have there is working out, okay, where do we start from? Let's draw all the way across the viewport, and that's the job done. The illustration above shows maybe the more complex setup, where we actually have to draw the background ribbon twice, or to draw 2 segments from it to completely fill the viewport. Because we've assumed that the viewport isn't wider than the ribbon is wider, then there's a maximum of 2 segments that we would need to draw at any particular point in time, and to stitch them together. And as long as it's a seamless ribbon, simply drawing them alongside one another will make it, will do that stitching, we'll be able to see the join. How we can actually manage this within code, easy way is to imagine, and it is only imagine, that the ribbon is repeated along the x-axis. So we only have a single image. We're not actually going to have multiple copies. We're not going to give a location of arrays where they're spaced along. We simply want to imagine that the ribbon repeats, in this case along the x-axis. If we do that, then it's actually very simple to work out, well, what is the index of the first copy of the ribbon that falls into the viewport? And we can do this using integer arithmetic. So viewport x minus viewport width over 2, this gives us the left hand side of the viewport, and we divide that by the width of the ribbon. And if you think about integer maths, that if it's within the first ribbon, or index 0, then say the ribbon's width 1000, 500 divided by 1000 in terms of integer arithmetic will end up 0. It'll give us an index of 0. If we had a value of 1002, so 1002 divided by 1000 in this case would give us an integer value of 1, in other words, index 1. So it's a very easy, very simple way of working out which version, or which index do we start off with. Given this, then, we know where that particular ribbon is located, its start location. And if we have a start location, we can then work out, because we know the location of the viewport as well, which portion of it falls within the viewport. And given that, we can then draw it as we would draw anything else. So it's no different than when we looked at the viewport and we said, here we have an object. This just happens to be a big object. How does it fall within the viewport? Let's work out that particular rectangle. So the previous stuff we did then applies at this point. To make things a little bit more complicated, and let's look at the general case now, where we have lots of ribbons, one or more, of potentially different widths. So this is the most difficult case, but again, it's worthwhile having a bit of a ponder about this, about how you feel you would do it. So I need to develop an algorithm that works out which bits of a series of images fall within the viewport. And we're going to assume that this series of images loops around on itself. It's not a single image. Here we have multiple images comprising our image ribbon and potentially of different width. So assume we have n images, I1 to In. They all have the same height, that make it reasonably straightforward, but they can be of different widths. So each image has its own particular width. Also assume that we have an array called image offset, and the index to this holds the start offset of image n. So image offset 0 is the starting location of the first image, which we can assume is really 0. And image offset 1 is the starting location along the x-axis of the image with index 1, the second image. Also assume that we have a viewport. Sure, that's what we're trying to populate. It's the same height as the images, and it starts in terms of the x-axis at VS, and it goes out to VE. That's the extent of it. So you might want to spend about maybe 10 minutes here having a bit of a ponder about how you would develop an algorithm that would enable you to selectively draw and to fill in the viewport. We'll have a look at an example of how we can do this. There's only one implementation. There are many different types of implementations. We're declaring a few variables. We go to the viewport offset. So this is how far through the viewport we are. So we have to draw out from one side of the viewport to the other. So our viewport offset will enable us to track how much of the viewport we've drawn. We have a draw offset, and this is going to be relative to the screen where we're actually drawing to. With an image index, it's going to tell us the particular image that we're currently drawing from, and a draw width, which we'll be calculating. This will tell us how much of the image do we want to draw into our viewport. So first thing we do, having defined all those different variables, is we want to work out, well, we have multiple images. What's the first one that we should select because it falls within the viewport? And you'll see when we get down to the end of the algorithm how we can wrap the viewport along, so there is always going to be an image that starts within the viewport. So we've got a while loop, whilst the image offsets, and here we're looking image index plus 1. So originally it's initialized to 0, so this is 0 plus 1 initially, the 1, is less than viewport x. We will go on to the next image. So what that does is that it steps through the images, and because we're looking image index plus 1, it's really looking at where the next image starts. And as soon as we find the next image that starts after the viewport begins, this is our indication that part of image index that we're currently on that falls within it. That's where we should stop. That's the first image that we want to draw out. So after we've done our while loop and we've worked out what is the first image that we want to draw, the next thing we have to do is to work out, well, how much should we draw? And there's a second while loop that comes in here. And whilst the draw offset is less than the width, in other words, whilst we still have some images that we can draw to fill in all of the viewport, we want to keep doing so until it's been completely filled in. What we have then after that is common to what we've looked at before. It's the simple calculation that works out, and you see the two cases at the bottom here, where we have the image that is fully within the viewport, and another case where the image starts within the viewport or only has a segment available within it. So we start off setting up our draw width, and the draw width is equal to the actual width of the image that we're looking at, but we take away from it where the viewport offset currently is. So that gives us, if you like, our starter for 10 about how much we can potentially draw. Then check to see if we were to draw that, would it take us beyond the width of the viewport? And if so, we cut things back just until we're filling in the end of the viewport. Having done that, we now know the particular region that we want to draw, and we can then draw that out. We're assuming again within this, because we're drawing from an image onto the screen, that we'll want to map one pixel within our image onto one pixel within the screen. But if that wasn't the case, if you had some degree of scaling, you would put that scaling in at this point. Having drawn that one particular image, and here we're still within our while loop, we want to step things on to go on to the next image. And then we'll work out how much of that we can draw, and we will continue that process until we've drawn through to the end. So what we're seeing on this slide at the bottom is the way of calculating, well, what happens when we go on to the next image. So draw offset, this is how far we've drawn through it. We add on to that the amount that we've just drawn. Our viewport offset, so this is relative to the world and looking at this ribbon. For the viewport offset, you can see here is viewport offset plus the amount that we've drawn, and then we're doing the modulus of effectively the end of that particular ribbon. So the way this one works is that if we have drawn to the end of the ribbon, we're going to loop around to the beginning, and our viewport offset will be relative to the beginning of the ribbon. So we'll start drawing pieces from the beginning. And we do the same with the image index. We've got an array of images. If we get to the end, we'll loop around back to the first image within that particular array. And that's it. Image ribbons, they are quite useful within a lot of scrolling games, particularly if you want to combine several of them together. If you only ever stick to a single image that we are drawing one next to the other, then they're very straightforward to manage. Though if you look for the general case, then that covers either having multiple images or having one very thin or very wide image and tiling it multiple times within our background. But all in all, reasonably straightforward, reasonably useful by way of your game.